And Will could not make it.
Hey guys, how are you? Welcome to the Monday stream, kind of the last one before Labor Day. Those of you who tune in with some regularity know that we've kept the activity alive throughout the summer and have gotten to a really good place in terms of our BOM for our next build and for our modifications to. Oh, if someone's got if someone can mute, unless that's me. There we go. I'm gonna let Ling in. So yeah, we're in a good place. We're in an exciting, very get down to brass tacks. Last couple of calls, a lot of great conversation on our Discord about some of the ideas that came up last week. And as we, just trying to think, if someone could go on mute just for a second, there seems to be a little bit of backdrop noise. There you go. So what we'll do today, as we kind of got to last week, what the big development was that we did decide to shift over to a tubular type of design or a pipe design, which we've been talking about for a long time. We've kind of gone back and forth on it, but Ling and David and others made a really good case and said, let's just do it. So I'm fully game for that. This is a little image of a tiny version of something that sort of inspired that another member of ours, Alex, made. It's a Epiphyte Junior, and so we're like, well, why not do that? So we talked about that, and then we agreed we really need to just figure out how the heating and air circulation part work, which is an important part. We have some ideas on that too. So cool. How's everybody doing? Everybody enjoying this last kind of week of the summer? Sweet. Great. We do have another member who's been in the chat a couple of times who hopefully will jump on again. She was on right before the stream started, but was having some internet issues. She is a petrochemical engineer based in Ghana and has actually worked on some plastic stuff as well. Took a polymer class in grad school. So some of these questions we have about the material that we want to use for the pipe and other stuff, she might have some interesting ideas on that. All right, cool. So shall we talk about the heating ideas? I posted a couple of pictures. If we're going with the convective heat, which sounds like we are, and we're going with a tube, I did find a couple of those really cool looking heaters. Here's an image of one right now that are meant to fit into ducts. This one here is pretty intriguing looking. So yeah, didn't know if folks had any thoughts on that.
It looks big.
It's like, I think there's multiple sizes for it. They're like, I think the biggest one is like 12 inches. So, we could find, ones that fit to whatever size tube we want to use, which will be dictated by the size of the monolith, I think, right?
The monolith should not be dictating the size of the chamber. What should dictate it is the convective mechanics, because it's easier to deal with a small piece of monolith, but then we can't fit anything in there, or like we can use a really big piece of monolith to capture carbon, but then now we're dealing with this massive thing, so we want to find the Goldilocks, right? Find something that is just big enough that we can fit our hardware inside, and then small enough that it doesn't get too unwieldy. So I haven't seen the pages, the product pages for these items. Do they come with these housings, or like?
It comes with, if you look at here's again, there's a few, which if you Google, the way I found these, I just did electric duct heaters was what I looked for. So just to share this picture here, this is one of them that I looked at. It doesn't come with this metal part, but that's just to illustrate how a duct would fit into it. So it's pretty simple. I don't know what this stuff is like in the middle, the heater. It looks like there's a lot going on there, but it's designed to maximize airflow. So I would imagine that is a consideration.
What's it made of? Is it plastic or metal?
That one's made out of plastic, and then obviously the heating elements are metal, and then there are the metal ones too, which if you look at this one that I showed before, this one's here, and that has like some kind of empty, mostly empty J box kind of, or box there, which could be interesting as something to fit in. And then there's several of them that are just like this though. But again, tube, heater right there, insert a tube into it. Seems like we're on potentially the right path with this type of thing if we want to go with convection, right?
Looks like the other one would distribute the heat more evenly. We don't want to have more heat, some of the little tubes in the monolith getting hotter than others because it's wasteful and inefficient.
This one, you mean?
Well, that looks better, yeah, because it looks like probably the heat is more evenly distributed around that disk.
Yeah.
I can't tell how the heat is distributed. If this gets red hot, then that's a radiative type of heating, which is fine. Like I'm not against whatever type of heating as long as it can get us up to temperature and we can distribute the heat. But I think it's worth noting that the monolith has a lot of surface area in the middle. So we can't just like rely on radiative heat alone. So that round black one,
yeah,
I think it looks like it's meant to attach to the end of an HVAC
yep,
pipe or something.
yep.
So yeah, so David, do you think it would be it's possible to mount it in a way where like you can distribute the heat? Because like right now if we're thinking about closing the dampers, it might be a pretty tight fit. Or like
I think you get a damper that's meant to fit with that. I mean, the good thing is there's dampers that are probably correspond directly to that diameter of pipe for HVAC, just like we found with the first one.
Isn't the heat distribution going to be somewhat a function of the distance between the fan and the monolith? I mean, we were talking before about having a very small distance to maximize the void or minimize the void, I guess. But if we need to put a little bit of separation to let that air mix, we can do that.
Yeah.
Yes.
yeah, okay, so wait, sorry. David, you were saying that we can mount a fan on the opposite end.
I was just
that is an interesting idea. That's maybe like feasible.
Like
I was
this.
trying to think through the whole thing. If we want to use convection, then we need to move some air through the monolith to heat it up. But then once it starts releasing CO2, as long as that air is moving, the CO2 is going to go out with the air wherever it goes.
Yeah, we got to close the dampers.
So we need to find a way to capture it as it's moving and doing the heating. Unless we're willing to sacrifice the first amount of it, let that go out into back out to the outside world. Then once the monolith is hot enough, it'll keep on releasing the CO2 after we shut both of the dampers. And then turn on the vacuum maybe. I'm just trying to, this isn't very coherent. I'm trying to think of different ways to do it. But the problem is, moving the air through as it starts releasing CO2 without wasting some of it.
So I don't know if you missed it when I was explaining in the previous weeks, but I was saying that to get a smaller fan to mix the air while the dampers are closed. This is why I didn't want a fan that spans the cross section of the duct or whatever shape that we're doing. And Jay did ask me at that time, how am I thinking about like the airflow, because if I blow air one way, where's what's gonna fill the negative pressure, and then what
Mhm.
about the air going out? Like, where's that air going to? And I said that we should mount the fan on one side of the chamber. So at the time we were talking about the double cone HVAC structure, and I was saying mount it like diagonally on the side so that it blows um, kind of along one side of the duct, and either just use that one fan, or have a second fan that blows like they don't blow at each other, they blow across, like past each other, so that it helps the air flow in a circular fashion. um and I was thinking that we get some heating elements, like something that gets maybe red hot, and mount it in the airstream so that it will help distribute the air that way. I don't know how that will work with like um the heat tolerance of the fans. It might get really hot.
Mhm.
But also someone, I think just now, David, when you were talking about um air being in a air being moved around and trying to capture carbon, that is a pretty big challenge, I think, that we'll have to face. Because like to keep up the temperature at 80-90 degrees, it's gonna be tough. Like that's not like close to ambient, and we're gonna be fighting the delta with the room temperature while this is going on.
Do you think, Ling, what do we think is required to circulate the air? It's obviously nothing like what we require to like fully pull the air through in phase one. Is it the kind of thing that can be very sort of mild, where it's a fan just sort of lightly pulling the air through, and it's not even necessarily constant, that it could be timed to just, I'm just trying to think of if there's a way.
What matters is, so when you're blowing a fan, it's 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 moving air molecule, right?
Yeah.
It's so one side of the fan, the air molecules are being pulled into the fan, the other side is coming out. And those air molecules, think of it like water. So if you're mounting it inside a chamber, like the source of this water, this air water has to come from somewhere. So you cannot mount it against a wall. If you mount it like right next to the dampers, and then you have the dampers closed, it has nowhere to pull the air from. And where the air is going is toward the other end, where the other damper is, and the air will be somewhat stagnant because um remember that the whole chamber is filled with air. It's not just where the fan is. So imagine like this whole chamber is right now filled with like this liquid, right? It's called a fluid technically. And so when you're trying to blow the fan toward the other direction, and if you haven't planned where your air is going to come from, you're going to have severe negative pressure behind the fan and positive pressure in front of the fan. So it's not about like the speed or the timing of the fan, but it's about how mechanically structure things inside so that we deal with the airflow. We want to engineer it so that the airflow is optimal. David has something to say.
Yeah. Well, I wish we had a whiteboard here that we could all sketch things on, but I think what I'm picturing is something like almost like a hair dryer, and it's in there in the middle, but it doesn't fill up the whole duct. It's just a small thing, and it blows hot air at the from some little bit of distance away from the monolith. It flows some of it through the center of the monolith, and at the far end it gets to the damper, so it has to sort of reflect back and go through the holes on the periphery, and then it comes back into the input of the fan and circulates around.
Yeah, so you gotta have fans that kind of like usher the air around. and the air is the carrier for thermal energy.
So it feels like this is problem that has been solved by air fryers.
By what?
Yeah.
By air fryers.
Yeah,
It's a small enclosed space that's circulating the heated air.
Ah,
So I found somebody's, I think it's KitchenAid's quick and dirty schematic. They have a quick and dirty schematic here of an air fryer. So basically they have the heating element and then the fan blowing down onto the food.
do you want to show it? Do you have that schematic?
I can put the link in the chat. I don't know how to share.
Yeah, go ahead and put the link. There's a share button on present that's on the bottom, Seth. That just like
there it
zoom.
is.
Yeah.
All right, let me pull this tab out somewhere else does it. Make a separate window.
Oh, I like that idea. But the thing you were just talking about, David, me and Ling kind of pointed in the direction of this a while back, was this idea of using like a heat gun, which is essentially like a small industrial hair dryer.
Yeah, I was thinking of using a soldering gun, like a soldering heat gun. I don't know what they're called.
Heat gun.
Is it called a heat gun?
It's called a heat gun.
Nice.
Yeah, so here's what I'm talking about. You've got the heating element on top, and the fan circulates through essentially what would be our monolith, right? The holes in the basket are essentially the monolith, and then there's a little bit of space down around it for the air to return and recirculate. So I think one thing we'd want to do is make sure, if we're following this model, is make sure that the monolith doesn't fill the entire cross section of the tube, so that the air has a place to recirculate. And we may actually want to
come back through the monolith now.
Well, but you've got the positive pressure of the fan blowing through the monolith.
Yeah, but I feel like the just food for thought. The fan blows through most of the monolith in the middle, but the side, maybe it doesn't heat up as efficiently, but just comes back through the side. It's okay. The whole thing is likely to be hot anyway.
Yeah, it's just we need to make sure that the air can actually circulate back up to the fan, the back side of the fan.
Well, I think the whole thing is porous, so it won't be too much of a concern. I just don't want to engineer something that the monolith is already doing naturally. Maybe the side won't heat up as fast as the center, but similar idea.
Yeah.
Well, what do you guys think about this? Basically, just like an air fryer shows the heating element is directly above a fan, which you could conceivably have the chamber, which has extra space, where you insert the monolith and there's a few inches, and you put a similar type of thing here. Like we've been thinking about putting the fan in front of the opening, but we could possibly do it from above or below.
I think I could see it going either way. There's probably an engineering or mechanical design reason with the air fryer that they're arranged like that, but I could see them coming in either order in our system.
It's better though to have it on top or bottom, probably potentially, just because it wouldn't obstruct the it wouldn't be in the way during phase one, right?
We still wanted to point it toward the monolith or through the monolith. So if it's above, then so this is a challenge for a reason, and I was thinking of mounting it more to the side, like not directly in the center, because we're gonna have the dampers open sometimes for capture. So like if you mount stuff in the center, it might block the air somewhat, and it might still work. But if you mount it above, then you have to be really careful, because like, are you still pointing the airflow toward the openings of the monolith, we want that airflow to be somewhat, has like a large parallel component, like component parallel to the monolith air channels. Gosh, my
How do you
English.
think? How do you think it would work if the heating element was above, but the fan was parallel? So when we're pulling air through, the fan blades can just turn with the pull of the fan at the exit. Um, and when the dampers are closed, the heat comes down and get pushed across. Is that, are we gonna? I mean, I guess that we would need enough. I don't know. What do you think?
You saw like those um I forget what they're called, the high watts things. Chris, can you like pull up the high watt things?
High watt.
The ones where there's like these heating coils.
Oh yeah.
I think if you just mount those in the center of the chamber, there's no worry about
That one?
no, not that one, but I mean it could be something like this. This one it looks like it's more resist, like there's more dead space. Yeah, something like this. If you mount something like this. So I was thinking of like the okay. I don't remember. I think it's called high watt, high HI dash watt, WATT. And it basically looks like this. Like there's a lot of air, there's a lot of negative space. So you don't have to move the heating element. If you don't want to heat, you just turn it off. If you want to heat, you just turn it on. And it doesn't block air or anything.
Right.
Yeah, these things are designed to be in air ducts and to allow air.
Exactly. That's why I love
Good
them.
point. Yeah.
Yeah. Yeah.
Question. I mean, if we follow what Ling just said about using that at the input, the fan on the other side, if you just run that with the dampers closed, would that be enough to circulate air within the chamber?
Would what be enough?
Would the make the fan that you're using to pull air through the monolith do double duty?
That's what I was thinking.
Yeah, if it's far enough away from the damper.
Yeah, I was thinking. I mean, this is not to scale, but the stuff that Ling is talking about though is that if you close it and you have a fan going, then there's a pressure issue. But I was just hoping that there might be a way that you could do a really light pull on that fan during the heating phase. But it sounds like, again, I don't know enough about those dynamics. Is that what you were talking about on the inside, Jay?
Yeah.
Yeah.
Yeah, then we need to do that air fryer thing. Let me think about how to engineer this.
So the other issue is if you put stuff in front of the monoliths, you may restrict it. It may restrict the airflow through it. I mean, the monoliths might restrict air a lot to begin with. It'd be great to get air through that. Laminar flow would be ideal, right? The turbulence will cause the air to get jammed up inside the chambers or the tunnels and slow the capture process. So, if I think of the monolith as a wing, you want nice smooth air over the wing, smooth air through the monolith. Seemed like it would be the most efficient way to pull air through it.
You're talking about with the fan?
Yeah. And then the other thing you could do is maybe you also have a little bypass that gives you a chance. You close the dampers, and maybe that opens a port through the outside the monolith, so that you can have air more easily flow through the chamber because it flows around the monolith as well. You can set up a circulation through it. You have the negative pressure from one side of the fan that's connected to the space around the monolith, whereas the other part of the other side of the fan, it sees only the, the monolith perforations.
Yeah, we can just use the original HVAC duct. The cone shape.
Yeah. So that means that
Um,
the thing that holds the monolith, assuming it's say it's circular, is that maybe you have an inch or so around the monolith that
Yeah.
allows this circulate, the air fryer circulation.
Yeah. I have to say I'm not sure if I disagree, but I'm not sure if I entirely agree that you really need laminar airflow
Well,
because
that would get the most air through. You don't need it, but that would get you the most air. You're spending energy with the fan trying to pull it through. When there's
yes.
turbulence, if you've ever poured a jug of water, it pours faster when it's not gurgling,
Mhm.
plugging.
Yeah, but I would say that the concern with turbulent airflow might be more in measurements. Measurements might be tough. But for like if you're talking about like capturing carbon, it might help slightly to have laminar airflow, but it also will slow down because like laminar flow, there's a formula and it depends on the speed of your flow through. So you can capture more when you flow faster, but maybe like then you'll have turbulent airflow. It'll be slower a little bit. So there's maybe a trade-off for capturing for desorbing for like mixing air. I'm not sure if you want laminar flow as much. In fact, I think you want the air to be a bit turbulent for the mixing of air. Yeah, so like when you think about like mixing cream into coffee or something, you don't want it to be perfectly laminar, right? So I'm not sure if I disagree. I'm just saying that like I'm not sure if being entirely laminar is. I think we need to collect evidence to know.
Go ahead, David. You have, I think.
Yeah, I tend to agree with Ling on this, and I was thinking of another analogy. If you've got the jug and you want to mix two things, say to make lemonade, you want to shake it up. But the other thing I was thinking of is each passageway through this monolith is like a tube, and if you have your air flowing through very well behaved, then only the air that's touching the surface will have the CO2 absorbed from it, and the air in the middle will never touch the surface, and so nothing's going to happen to it. But if it's turbulent, every little piece of the air will have an opportunity to touch the surface.
And that's more during phase one, though, right? You want sort of like a real
Phase one.
heavy, yeah, exactly.
Yes.
Yeah.
I mean, it feels to me like these are great problems to solve in the next gen.
Yeah, these are more like micro
next iterations.
Yeah,
these are optimizations.
Yeah. What do you guys think about the like? There was something I posted. I was just doing basic research here, finding out like are there alternate ways in which we could move the heat from one side of the tube to the other one that maybe don't involve a fan or something the way. Did you see those things I put in there they're called heat tubes? They have like a sort of a phase change where when one side gets hot, that reminds me of the way passive solar trackers work.
I looked at those, and you're not gonna be able to heat inside the monolith very efficiently with those. Those are basically just like conductive, those are basically just nichrome wires in another form. And if you want to have more surface area and heat like more evenly, I think those will do the job. But we still need to heat inside of the monoliths, like the inside surfaces. And I think without air, you can't do it efficiently.
Mm-hmm.
because it's gonna be like one hot element, right? And it's either gonna be conductive or radiative. If you want to pass the air into the monolith, you need another carrier.
Yeah. Okay. Well, what are we thinking? So I think we like the general.
Jay has a question.
Oh, go ahead, Jay.
Or
Just another
something.
question. Do we have access to a fluid dynamics modeling tool? Does like FreeCAD have a fluid dynamics tool?
Or Charles at UT. I wonder if we have one. I don't even know what it is. So, Charles, I don't know if you heard that question, and you're on mute. You might have stepped away for a sec.
Unfortunately, as one of the more mechanically inclined person here, I'm not great at modeling.
Modeling is its own specialty, right?
Yeah, I've done
really
it, and
hard.
I'm like, I have no idea if it matches reality or not.
Every simulator, yeah, that you can say that, but it'll give us I like them, like circuit simulator, Spice. I used to use them as a starting point. You know, you've got a lot of variable space, and they help you eliminate some of the variables, and it's a place to start where you can then build something in.
Yeah, let me see. Oh wow. Okay, I looked up console alternative, and there are so many different ones. Oh, there's OpenFoam. I wanted to look into that, but I didn't end up spending time on it. Well, any free one is gonna be kind of hard to use.
So what, that was the flow.
Yeah.
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 Okay. Hey, Abina. So I mentioned Abina before. Abina's been on the chat side of things before. Great to have a new member hop in. Abina, I don't know if your internet issues have been solved, but if you want to just quickly introduce yourself.
Hi.
Hello.
Cool. And you're in Ghana, right?
Sure. Hi, everyone. Am I audible?
Great to have you. The connection's a little weak.
Audio.
Yes, I'm in Ghana. Can you all hear me?
Yeah, we can hear you now.
We can hear you, yeah. Oh, no.
A little frozen. Yeah, well, the connection's a little frozen, but we're glad you can hear us. So we have the private chat bot there. Or in the comments, if you have ideas, you can still type them in on this side of the screen. But awesome to have you in the loop, and we'll get your Wi-Fi going for next meetup. But you had told me you're a petrochemical engineer, so I was excited about that, and that you have some experience with polymers and stuff like that, which was really cool.
You're on
mute. You're muted right now.
Okay, she's got it. All right, cool, awesome to have you here. Bring friends. We're going global. So what were you just getting at though, Jay, with the flow thing?
Yeah.
Oh, I was just wondering if there was any simulators we could use to help us identify starting points.
We can ask, see what they have at the UT lab. Just to check a couple boxes. I mean, do we like this? Obviously, we have choices to make around cost and stuff like this, but we generally like this type of thing, right?
Yeah, if we can have like, I'll post. I don't know. I don't think I need to post the link. I'm sure it's on the Discord.
Was it one that I shared?
Yeah. It's the high watt thing. I think it's just like a little bit of hardware plus coils. They're not exactly coils, but they look like what's on the screen now, like the heating elements.
Yeah. Oh, from last time.
I guess.
You mean the one where it just showed?
You posted it before, definitely.
Yeah, I think you're talking about this one here. 1 second. It was. I have a picture of it. I don't have a picture of it. Yeah. So from last week, I mean, I think the thing I just like about this is it lends itself to a tube, and it's got exactly, you know what I mean? And it comes in multiple sizes. So rather than having some independent coil that we then have to think of a way to fix inside of it, why not just have something like this? Is, I guess, my thinking.
Mm-hmm. Yeah. Let me see if I can find.
Okay. Well, I put those links in there, and there's many other varieties. There's ones that have like a perfect circle, but again, all designed for air to flow past them and to heat up air. So it seems like, no reason to reinvent the wheel if we could get something like that. They seem to be relatively affordable as well. Like they range quite a bit from like $40 to like $150, but nothing that will completely break the bank. So we can look at a few more options for that. But if we kind of are attracted to that idea of having this thing that also comes with this nice round sort of fit area that you can put a damper on the other side of, let's keep pursuing that. But where are we now with the fan? What do we think in terms of the positioning of it? I'm trying to visualize that with something like this. Just disregard the order of the fan there. Pretend it's on the other side of the damper. But like, where do you put a fan where it's unlike the last thing we had where, Ling, you were talking about putting it on the diagonal and it kind of blows upward? Like, what would we do?
Yeah, you can put it. So if the fan it doesn't span the whole cross section, you could put it in the middle, and then you could still use it to pull air through the chamber. I don't know. That might be a bit tough. You might get some dead zones.
Yeah.
I have to think more about this because this is a harder problem than it looks. Anyway, I put the heating element as a link in the chat. The one that you shared, Chris.
Oh, that one. Yeah. Well, I mean, that's just that heating element essentially without the case.
Yeah.
Yeah. So
and I think I like it without the case because like you still have to integrate the case with the rest. But
it so lends itself to that
debate.
though, because it's round and it comes in many different sizes and it has feet on it.
If it comes in different sizes, that's fine. Yeah. There's just usually more flexibility with parts that are more modular. You're like less restricted on putting it in one place. Okay. I gotta think about the airflow in this case, but it's probably possible. Yeah, so I don't know if everyone else knows what I'm talking about. Like if your fan is smaller, then you can run it while the damper is closed, but then when your damper is open, you'll get dead zones on the outside perimeter.
Jay, when you were just talking about the thing before, were you thinking almost like you'd have like a tube that would go? I can't see where I'm clicking on, but like see where I currently have where it says fan. So pretend that's not a fan. Just pretend that's part of the tube. Or maybe you have a fan there, right? Like a small fan, like what Ling is talking about. But if you have like a little pipe that went as a downspout from there, and then it went underneath again back to where right in front of the beginning of it, like in front of where the duct heater is.
Yeah.
So it could you're pulling air towards you, and it's gonna, if it has to go somewhere, it's gonna go down through there through the pipe, and it's gonna recirculate. Was that what you were describing, or like?
Yes. Okay. But
it's
that has to be blocked when you're pulling air through the monolith.
Yeah.
Otherwise, it'll just be bypass, right? It'll just bypass the monolith because it'll be less resistance to the flow probably.
Do you get the same effect though if you without a pipe and you just have enough space in the chamber itself between the monolith and the walls?
Don't know.
Because I'd prefer to do that, obviously, than introduce some other thing that requires putting holes and stuff. But
it doesn't matter where the monolith is because the monolith is so porous. Okay, so I thought about it for like 20 seconds, and I think that if we need to engineer something ingenious to allow the fan to work double duty, we might as well just get extra fans and just turn the different ones on for absorption and desorption. I think it's just simpler and saves engineering time and effort.
Yeah. Okay. But still, it's kind of, we then have to figure out where do we put that, I guess.
We just get a longer chamber.
What do you mean?
our chamber, like the whole chamber, can just be a bit longer to allow
Oh, yeah, I see.
for us to put this stuff inside.
Did you see that other fan for that purpose that I put in laying in the Discord? It was a
The oven thing?
yeah, not the
That's
one.
not gonna work, I think.
No, not that one. Sorry, the one that was it was one of the it's called a Mingle Tech, which it's this one here. Wait 1 second here. I wonder if something like this could work. Let me just share my screen real quick. Screen, boom, boom, bing, bing. Can you guys see that?
Oh, this. Oh, I don't know why there are dampers in the
Yeah, I don't know why either. But anyway, like something that's very thin where you can even take off the back part. You just use that whole fan.
Exhaust fan. Okay, so I don't know. I think you suggested this because it's metal, but we have to look at the specs of the fan to make sure it's within operating temperature range.
Yeah.
Because it's not necessarily plastic that's gonna melt, but it's also other components.
How hot does it get inside of a computer for computer fans and stuff like that, or even server? If you looked at something that would go into like a server cabinet or something that's a fan, probably not degrees C, but
I think it could get up to pretty high. Yeah, they may work. We just gotta look at specs and like make sure that we can hook it up electronically.
Yeah.
Which I'm not an expert of. But yeah, I think some computers do get up to like 90 degrees, which is pretty high.
Not to sound like a broken record, but we should look at air fryer fans.
Yeah, no, I love that idea. I'm curious if we can get that. This is one just to look at something that's a little smaller. It's like a computer fan. I have to look and see what the heat tolerance is of it. But yeah, I wonder if you could just buy an air fryer.
So we gotta look at the anatomy of an air fryer fan, and it's cheaper to look at schematics than to just buy one and take it apart, right? Because I was looking at fans for convection ovens, like convection oven fans, because they go up to like 400, 500, I don't know, maybe like more Fahrenheit, which is, I don't know how hot that is, 150, 200 Celsius or something. And the fan is like, it's kind of big, and the fan part is mounted inside and it pulls hot air into an area outside of the oven. I have to study it a bit more. I wonder if air fryers are similar.
The one I just put in the chat here, the comments for here on StreamYard, is apparently when I googled air fryer fan. I'm not sure if that's specifically for air fryer, but it's a nice little small thing that's rated to go in very high heat environments. It looks quite small. If you guys saw that, let me just see if I can add this here. So something like this looks pretty. It looks a lot like the other thing, but it's meant to be very, very hot. Just wait for the picture to upload. And it looks pretty small. I'm not sure what the dimensions of it are, but this guy here, again, it's a lot like a computer one, but it's for ovens. So
we have to see what it does for the oven, because I'm not seeing specs.
Yeah. Okay.
I think the fan in our convection oven was belt driven, so the motor was not in the heat area. Just it had like a polyimide belt.
Mm-hmm.
And those are good to like polyimide is good to like at least 300 degrees C, I think.
Yeah, it's pretty high, maybe even higher.
Yeah. Likely.
I also just found a replacement lower fan blade for a dual basket air fryer for $7. That's circular and very, very simple, that we could, potentially look at. It's this guy right here. You can see that. I mean, again, I don't know what the electrical components have, but it looks like it's got something else here. Cord. Anyway, yeah, I guess we just got to figure that out.
Yeah, we'll do some research. Yeah, I'm not very good at looking stuff up online, so this gives me some ideas.
Yeah, I could try to just get a bunch of links and just sort of pop them up there for you guys to look at that fit the, high heat, non-melting, but not like, because we don't need a lot of air for the circulation, right? It's just a relatively small amount that just pulls it in the right direction, right?
Correct, depending on the chamber size.
Yeah. I mean, I love the idea of it being pretty snug, right? Like we don't need to have a lot of extra air in there that we don't need to fit the monoliths. And it's also cool if you do a longer pipe, could you line up two monoliths so that their cavities are exactly aligned? You could even glue them together. It just gives you more absorbent capacity, but to not like leave a lot of dead air in there.
For the dampers, what's the pressure that they can handle? Differential pressure.
I don't know. There's a lot of options though. David, when you and Chuck talked about this with like damper selection, I'm sure cost kind of ruled the day there, but we always thought that they were a little too flimsy and maybe leaky. But there's other ones too that I saw that have like a rubber gasket. It's like a snugger type of fit that are a little bit more heavy duty. So it seems like there's some other options there, but didn't know what happened when you guys originally spec'd that out and use it.
Well, we looked at them. They were too expensive, and Chuck understands, but I don't, how you spec something like that. In other words, how do you quantify the air tightness of it? And I did see dampers or valves, they call it, they were meant for vacuum systems where it has to tolerate a very high vacuum, but those are really expensive, like in the thousands of dollars. So
Yeah.
we skipped over those.
Yeah, good call. Well, we could there might be something in between that. Like I had a picture of the one that kind of showed the you can see like a little gasket, the dampers right in there. It's got like this rubber part, and if I remember, they weren't that expensive, but just a bit of an upgrade, I guess. It's probably possible without putting down a few $1,000s. I think we're going to save money. Oh, the other thing too is on the PFTE tube, which I think I mentioned on the Discord, is that stuff is expensive. Like I was surprised the Teflon tube there wasn't cheap. I was hoping we'd get some savings out of going with a tube compared to our last thing that we used, which was about like $300. But but there's other options, and me and Abena were talking about that. Like I was talking about like a PS. There's another material called a PSU, which can be like 200 degrees C, which is cheaper. So we'll have to get it out.
So are we talking about like using PVC type thing for plumbing and
I'll read more on that and get back.
a
Okay.
4-inch diameter tube, or is there something bigger? After 4 inches, I'm not too familiar what's available and stuff you can buy at Home Depot.
Yeah, I found like a 10-inch tube that was PFTE. Is it PTFE? Teflon, whatever. Which gets us a little bit closer. We could get like a 6-inch monolith, and it would still give us some of the space we need. It's not like the kind of thing you're going to buy at Home Depot, but you can order it. Definitely more than 4 inches. We'd want to be able to have something big enough where you can get like a bigger monolith, and I think can still have some space.
Okay. All right.
Just a quick question here. Our friend J3ANX just asked a question here. Did you guys think of how you're going to cool the monolith? I don't think we really. Do we have to cool the monolith actively, or do we just let it sort of do its thing? And if we're constantly going from cycle 1 to cycle 2, that opening it up and then blowing air through it, I guess, will solve that problem, right?
I think that desorption is supposed to happen in a vacuum or in a heated environment, and then afterwards we're just like done, right?
Yeah.
Or so I thought.
I mean, it might slow down the rate of adsorption when we go back to that phase. The monolith is warmer, but I don't know that. Again, that's an optimization problem, not a.
And I would imagine that would be, who knows how long it takes, but once we go back to absorption, we open it up and we're blowing a fan and pulling air through it. I would imagine that'll help with the cooling somewhat rapidly,
Do we have a monolith that we want to start with identified?
I'm going to ask Kirsch again, but he thought that we could get along with off-the-shelf catalytic converter alumina monoliths, and the benefit of those is they're actually circular, and they come in a few different sizes, but they're obviously meant for that use case. But there are 6-inch ones, so you can just get like a 6-inch diameter catalytic converter monolith and use that made out of the same material.
Okay, the PSU sound looks promising, so I'll look into it.
Okay.
By the way, it's Chris. Chris is a PTFE.
PTFE, right?
Yeah. Polytetrafluoroethylene.
Yeah.
Teflon, basically Teflon.
Yeah.
Yeah, it is Teflon. Yeah. I was acting like an idiot last week when our friend J3ANX was saying it, and I kept thinking they were two different things, but they're the same thing. So, but really crazy. Yeah.
There's just the spelling on the slide.
Yeah.
PTFE.
This is kind of interesting. It looks like crap, but I'll show you guys anyway. I was just looking up catalytic converters. Is that you get you can order things that actually have. There's the honeycomb inside, right? Like they come in this sort of shell, but I guess you could pop it out. But you see how that looks, Jay? It's kind of
yeah.
That's what we're talking about. So it's kind of perfect food,
Okay, this
Can you put
changes
that
this
link in
changes
the
a lot of things.
chat?
What changes a lot of things?
This looks highly resistant, like airflow wise.
Well, if you go, I mean, basically, we can just look at what Hirsch and those guys use. You know what I mean? Like if that works and they send air through it, we can look for. There's ones also that have much wider space, but the benefit of ones that have smaller ones obviously is more surface area. So we'll have to just kind of make a trade-off, I guess. I don't know how to calculate what's optimal for that. Surprise, surprise.
It affects the way we engineer the airflow. I have to think about the airflow differently.
Is there any way to look up, or is there a spec for the resistance to airflow? You probably wouldn't find that on Alibaba, but it seems like there's probably a standard for it.
Yeah. What would be a smart thing for me to put in Google for that? So just catalytic converter airflow resistance. There's got to be somebody who's written something about that.
You can just do back of the envelope calculations for resistance. There's simple equations, so it's cross section, length, like all this stuff.
There's an article I just understanding flow through catalytic converters, and it has a bunch of formulas in there. So I don't know.
I think you don't need to look at a complicated thing. You can just if you understand the basics of air resistance, it's the same as electric resistance. So something that is has smaller holes, and the hole, maybe it's a pipe, and the length of the pipe will be, I think, proportional to the resistance. So the longer the pipe, the higher the resistance. The smaller the opening, the higher the resistance. That's pretty much it. So if you're looking at those monoliths that have those grid openings, those are quite porous, and I wouldn't expect them to have too much different resistance than just open air area. But with this catalytic converter, I would expect significant resistance. And so if you have any kind of like larger opening on the side, air will for sure want to go through there instead. So we gotta like force it through the catalytic converter, but which is fine. We just have to design for it, and it's not so easy to exchange them afterwards.
So you're worried, you're basing that on the size of the channels? Is that what you're saying? That the channels are so small? That yeah. So there are other options. It looks like there's quite a bit of variety in the kinds that you could get in terms of how narrow those channels are. So like for instance,
I think we should just pick one and stick with it, and not like, as long as it's measurable. We just care about being able to measure the results afterwards. So how big the opening is, we should just choose something that's simple for us to prototype and not worry about like, will it capture the most carbon? I think we just need to capture a noticeable amount at this point.
Well, yes and no. I'd like to, within what's within our control, at least, if there is some way we could do some math to sort of figure out what's the Goldilocks there, where if we're packing more sorbent into a monolith that has more channels, but that is going to lead to more resistance, we should probably, we
gotta look at engineering complexity, right? To save cost.
Yeah. But you see this here, just to give you an example, like this one has way more air, like much bigger channels length. You can see that. So we have options.
Yeah.
All right, cool. Well, we're out of time. I'm not sure if we made any. I think we made some progress. I think Ling, if we can keep up the chatter around this question here of what we might want to go with. Again, it just seems kind of perfect. Something like this.
Can you post the product pages in the Epiphyte channel? Yeah, I need to know how big these things are, or like what it comes with and stuff.
Yeah, I'll take a look at that. So, but if we go down that direction, and then with the fans, we can look a little bit at there are vendors of air fan or air fryer kind of replacement parts and other things that are used in ovens that I'm suspecting that we want to go down that sort of direction.
I need to do some homework, but it may not be feasible. It may just not work the way you think. So let me do some homework.
Okay.
Let me study that on my own.
All right. Yeah, just pop up what your thoughts are on the as you usually do on the Discord, so that we can have some interaction with it. Cool, guys. It's 1:59 Central Time, so we can tune off now. But appreciate everybody joining. Bana, it was great to have you join, and you had to hop off because of internet issues. But all right, I'll see you all in the Discord. Next week's Labor Day or Labor Week, or is everybody back by that point that we should keep our Thursday call, or
I should be.
Okay.
I should be back too.
All right. So same place, same time next week. Bye, everybody.
Bye-bye.